Exercise 1.4, question number 1. We are given a curve y equals to x cube. How to draw this curve? Just we'll have an understanding. Put x 0, we get y equal to 0 cube. 0 cube is also 0. Put x is 1, y is 1 into 1 into 1, 1. Put x is 2, y equal to 2 into 2 into 2, that is 8. Same idea I can put for minus values. So we have taken the various x values and y values. Let us plot it. 0, 0, 1, 1, 2, 8, 3, 27. The same idea down. Minus 1, minus 1, minus 2, minus 8, minus 3, minus 27. So we have drawn the curve y equal to x cube. Just joining all the points we have extended. Now this will be given in the question. Then what is that you have to do? Find y equal to minus x cube. This y equal to minus x cube, I can say y equal to minus x the whole cube or minus x cube. So, reflect y is equal to x cube about x-axis. What do you mean by about x-axis? The curve will be reflected like this. So, this is y is equal to minus x cube. The same equation can be written like this also. Minus x the whole cube. So, this is my original curve y equal to x cube. When I want y equal to minus x the whole cube, it is reflection about y axis. I can draw like this also. So, this curve either you reflect it by x axis or you reflect it by y axis to get y equal to minus x cube. So, this is the diagram. The original diagram goes like this. If I rotate like this, now about y-axis I have done. I keep it like this. When I do it like this also, about x-axis, the same thing. So, this particular equation alone, I can say reflect about x-axis or about y-axis. Now, coming back to the question. This is y equal to x cube. What I want is y equal to x cube plus 1. What do you mean by plus 1? The diagram shifts up by 1 unit. So, it will be like this way. Shifts up by 1 unit. So, this is my original diagram. Shifts up by 1 unit. So, it will be like this way. My second question, x cube minus 1. This is my original diagram. Now shift it down by 1 unit. It will be like this. So this is shifting up by 1 unit for x cube plus 1 and shift it down by 1 unit. That is for y equal to x cube minus 1. Now this is the original question. We have to find out x plus 1 the whole cube. X plus 1 comes, shift it left by 1 unit. So, this is the diagram. Shift it left by 1 unit. So, we have the 4 diagrams. One is reflection, or I can say like this way. The second one is given diagram shifting up by 1 unit. Or third one shifting down by 1 unit, or fourth one shifting left by 1 unit. Let us draw it all in various colors to identify. We have drawn all the curves together. X cube minus 1 comes down by 1 unit. X cube plus 1 goes up by 1 unit. X plus 1 the whole cube shifts to the left by 1 unit. And these are done by reflection and translation. Exercise 1.4, Question number 2. Given y equals to x power 1 by 3. Let us remember y equal to x cube is drawn like this. X power 1 by 3 is the inverse function. How should I draw? It will be reflection about y equal to x. So this is the diagram. Y equal to x power 1 by 3. My next question is, for drawing this you can also use the table. Put x is 0, cube root of 0 is 0. Put x is 1, cube root of 1 is 1. Put x is 8, cube root of 8 is 2. Like this we can put some values and draw the curve. Many a times they give the curve in the question itself. What should you do? Draw y equal to minus x power 1 by 3. Now y itself is becoming negative. So here we put minus symbol, implies reflect about x-axis. This is the diagram. Reflect about x-axis. My original diagram was like this. Y equal to x power 1 by 3. What I want is y equal to minus x power 1 by 3. This curve reflect about. So this is reflection. Reflect about x-axis, and this is the diagram for y equal to minus x power 1 by 3. Go on to the original diagram. This is y equal to x power 1 by 3. Second question, x power 1 by 3 plus 1. So this is y is equal to x power 1 by 3. Shift it up by 1 unit. Shift it up by 1 unit, and this is the diagram for y equal to x power 1 by 3 plus 1. Third question, this is y equal to x power 1 by 3. We want x power 1 by 3 minus 1. So minus 1 tells me shift it down by 1 unit. So this is the diagram for x power 1 by 3 minus 1. This is x power 1 by 3. My fourth question is x minus 1 power 1 by 3. X minus 1 tells me shift it to the right by 1 unit. This is my original. Shift it to the right by 1 unit, and this is the answer for x minus 1 the whole power 1 by 3. We will try to draw it all in different colors. We have the diagram y equal to x power 1 by 3, the base diagram. X power 1 by 3 plus 1, shift up by 1 unit. X power 1 by 3 minus 1, shift down by 1 unit. X minus 1 whole power 1 by 3, shift it to the right by 1 unit, and that is the answer. Exercise 1.4, question number 3. Graph f of x equals to x cube and g of x equals to x power 1 by 3. We need to find f composition g and g composition f and show they are inverses of each other. The very first idea, let us plot it. What is f of x equal to x cube? Let me put x, some easy values, 0 plus or minus 1 plus or minus 2, and 3 also I can put. So what is y? 0 cube 0, 1 if I put 1 cube is 1, 2 if I put 2 cube is 8, minus 1 I put minus 1 cube is minus 1, and I have tried the remaining. The same idea, x power 1 by 3. Now the reverse I have to put. All y values I will take for x, all x values will come over to y because it is cube root. Here it is cube. So x is smaller, y is bigger. Here it is cube root, x power 1 by 3. So just reverse the values. 0 I put 0 cube root is 0. 1 if I put, cube root of 1 is 1. 8 if I put, cube root of 8 is 2. Minus 8 I put, it is minus 2. Minus 1 I put, minus 1. Let us plot these two graphs. First this one, 0, 0, 1, 1, 2, 8 somewhere here and 327 will be somewhere here. The same idea, so the diagram goes like this. Minus 1, minus 1, minus 2 I put, it is minus 8 and 3 when I put, it is 27. So how the diagram will be? It will be like this way when I plot it. So we see this curve is y is equal to x cube. When I plot this one, 0, 0, 1, 1, 8, 2. 8 will be somewhere here, 2 will be here. So 8, 2. And then when I put 27, it will be 3. So 27, 3 will be here. Same idea. So the diagram goes like this and it will go on down. So how the diagram will be? It will be like this. Now what we see? The line y equal to x, symmetrical about the two curves. So the two curves are symmetrical about the line y is equal to x. And so immediately I can say these two are inverse functions. So whenever the two curves are symmetrical about y equals to x. What is y equal to x? It is a line joining 1, 1, 2, 2, 3, 3 and so on. Similarly here minus 1, minus 2 like that way. So this line, whenever I find the two curves are symmetrical, I can immediately declare they are inverses of each other. Anyway, to prove it mathematically using the algebraic concepts, what is f composition g of x? F of g of x. What is g of x? X power 1 by 3. What is f? The whole cube. Whatever is coming, the whole cube. So 3 and 3 will get cancelled. I am left with x. So f composition g gives me x, tells me this is I. F composition g is I. X goes to x itself. The reverse. G composition f of x. Keep g as it is. What is f of x from the question? It is x cube. What is g of x cube? G tells me whole power 1 by 3. So x cube whole power 1 by 3. Again 3 cancels. I am getting x. F composition g is also x. G composition f is also x. Tells me f composition g and g composition f are nothing but yielding me identity function. That is, inverse of f of x is g of x, inverse of g of x is f of x. Or I can say f and g are inverses of each other. F of x equals to g inverse of x. And moreover, we write the two functions or the represented curves are symmetric about the line y equals to x. So graphically I have proved they are symmetric about y equal to x. Algebraically I have proved f composition g and g composition f are giving me identity function. And so in both the cases we have proved f and g are inverses of each other. Question number 5. Y equals sine x. Now sine x, we try to draw the curve. We know trigonometry values for sine. Now in detail we will study latter chapter trigonometry. At present you remember sine 0, 0. This we have studied in standard 10. Sine 90 is 1. Instead of 90, this here we will mark pi by 2. 180 I call pi. So pi, 2 pi, 3 pi, all these values, any multiple of pi is 0 in sin x. Minus pi by 2, minus 3 pi by 2, like this it goes. The value will be plus 1 and minus 1. Plus pi by 2 plus 1, minus pi by 2 minus 1. Plus 3 pi by 2, the value is minus 1. See how we plot it. 0, 0, pi by 2, 2 pi by 2, 3 pi by 2. Like that we have taken the scale for easy plotting. The left side, minus pi by 2, minus 2 pi by 2, minus 3 pi by 2 and so on. Plotting 0, 0. For pi by 2 it is 1. For minus pi by 2 it is minus 1. For pi it is 0. Pi is nothing but 2 pi by 2. 2 cancels. And minus pi also it is 0. 3 pi by 2 when it comes, the value is minus 1. Minus 3 pi by 2, my answer is plus 1. See how we see the curve? It is like a wave moving up and down. And it doesn't go 2 up or 2 down always. The highest value is plus 1 and the lowest value is minus 1. So the curve sin x oscillates between plus 1 and minus 1. It goes on and on as I draw. Now, this is basic idea of drawing sin x. What is the question? Sin of minus x. X is changed as minus x tells me it is reflected on y-axis. Reflected on y-axis tells me we just reflect like this way. So, see how the diagram goes? This is my original diagram, and if I reflect, up will come down, down will go up. So this is sin of minus x curve. The thick red line tells me it is sin of minus x curve. When I want y equals to minus sin of minus x, this thick red line tells me it is sin of minus x as I have reflected on y-axis. Now sin of minus x, I have to reflect on x-axis because my question is minus sin of minus x. So reflect on x-axis, draw it like this way. This is the diagram. Reflect on x-axis, draw it like this. So I got the original sin x curve. So minus of minus, remember it will get cancelled in trigonometry when it is sin. Minus of minus will get cancelled in sin and we get minus sin of minus x gives me the original curve back. Now, third part of the question is y is equal to sin pi by 2 plus x. This is sin x curve. This sin x curve I want to shift. Plus pi by 2 tells me left by pi by 2 units. This is pi by 2, this length. So shift left by pi by 2 units. So this is the diagram. Shift the original curve by pi by 2 units to the left. Plus pi by 2 tells me to the left. So the thick line again tells me sin pi by 2 plus x. Now we have the original curve like this and we want sin of pi by 2 minus x. This we rewrite taking minus sign outside. It is sin minus of x minus pi by 2. My first idea, draw sin minus x. So how to draw sin minus x? Reflect on y-axis. So this reflect on y-axis. So this is my idea. Reflect on y-axis. The thick red line shows me sin of minus x. Now I have minus pi by 2. This tells me shift to the right by pi by 2 units. This is the diagram. Shift it right by pi by 2. Right. So we have come like this way. So this is the diagram sine of pi by 2 minus x. The thick red line tells me sine of pi by 2 minus x, and this is nothing but cos x curve. So we will study in trigonometry later. Sine pi by 2 minus x, the thick red curve, is nothing but cos x. Question number 8. Draw y is equal to sine mod x. Now what is meant by mod x? It is x when x is greater than or equal to 0, or change the symbol. Sign of minus x will come when it is less than 0. So mod x tells me keep x when it is positive, change the symbol when it is negative. So this is the original sin x curve. When x is positive, treat the curve as it is. When x is positive, the sin x curve is as it is. But when x is negative, this part is wrong. So how should I do that? When x is positive, treat the curve as it is. But when x is negative, let us change. See the diagram. X is positive, we draw the diagram like this. When x is negative, I have to write minus sin x, that is reflecting. So this will be the diagram. The original diagram was down actually, but when I change the symbol, it will be up. Here it is up, which will become down. So look at the diagram. This is sine mod x diagram. Here how it is coming, the same way will come in the left side also. So this is y equal to sine mod x curve. Now each of these questions we'll see once again in detail. First part, y equal to sine of minus x. This is original sin x curve which we had learnt in the earlier case. Minus sin x tells me put it question number 5 subsection 1, y equal to sine of minus x. So this is sin x diagram. When I say sine of minus x, we just reflect it like this. So this up part will come here, this down part will go here, which we have drawn. Second subsection, minus sine minus x. Minus sine minus x will give me the same old sin x curve. Sine pi by 2 plus x tells me the sin x curve shifts to the left by pi by 2. So this diagram will shift by left. Shift pi by 2 left. So the diagram goes like this way. The next one, sine pi by 2 minus x, which we rewrite sine of minus symbol out, x minus pi by 2. And the diagram will be like this way. Sine of minus x, this is the curve, shifting right by pi by 2 units. So this 0 will come here. So this blue curve will shift here by pi by 2 units. And this curve is nothing but cos x curve. Sine pi by 2 minus x only will come for cos x also. The eighth one, sine mod x. We remember sine mod x will be sin x when x is positive. So the same old diagram like this will come. And it is minus sin x when x is negative. So this is reflected like this way. So here also, this was down, but because I change the symbol, this will go up. This was up. Because I change the symbol, this will come down. So this diagram reflect, and that is my answer. So sine mod x will be like this way. Here we have given you an idea for cos x. To check, cos x and sin pi by 2 minus x both are one and the same.